So what we're going to look at here is a Kata that's already defined, which is more about refactoring legacy code than it is anything that I've done before. So prior to this, I've been mainly doing test-driven development examples. This is a already existing piece of code written in C#. I've already forked the repository into my own GitHub, which I'll make public at the end of this series. And I'm just going to clone that down to my machine now. But this Kata is about doing a bit of legacy code refactoring, introducing tests, and then making a change. So we're just going to pull this into Visual Studio, and I'm just going to do a couple of things just to make sure it kind of compiles. I've speeded this up just because it's quite tedious. So we've got a set of tests that don't run. They also don't do anything. So those tests do not assert anything useful, just asserts that true is in fact true and is being thrown out by the test framework that I'm running. The code itself is a sort of really big function. So lots and lots and lots of nested if statements, so on. We've got multiple classes inside a single file, so there's a few things that don't really feel, 100% right. So on the note, we're just going to see if we can get this to kind of compile and run. And also you'll notice that the console app in this doesn't actually do anything. So now I've got the console as the default. We should just be able to build this. Says we're okay. And we get a console window that just outputs some text. We're going to look at the Readme that comes with the repository. So this is just part of what I've cloned. It's not written by myself. So hi and welcome to the team Gilded Rose. As you know, we are a small inn in a prime location in a prominent city. I think that should be run by a friendly innkeeper named Alison. We also buy and sell only the finest goods. Unfortunately, our goods are constantly degrading in quality as they approach their sell-by date. We have a system in place that updates our inventory for us. It was developed by a no-nonsense type named Leroy, who has moved on to new adventures. Your task is to add the new feature to our system so that we can begin selling a new category of item. First, an introduction to our system. All items have a sell-in value, which denotes the number of days we have to sell the item. All items have a quality value, which denotes how valuable the item is. At the end of each day, our system lowers both values for every item. Pretty simple, right? Well, this is where it's going to get interesting. Once the sell-by date has passed, quality degrades twice as fast. The quality of an item is never negative. Aged brie actually increases in quality. The older it gets, the quality of an item is never more than 50. Sulphurous, being a legendary item, never has to be sold or decreases in quality. Backstage passes, like aged brie, increase in quality as the sell-in value approaches. Quality increases by 2 when they are 10 days or less, and by 3 when there are 5 days or less, but quality drops to 0 after the concert. We have recently signed a supplier of conjured items. This requires an update to our system. Conjured items degrade in quality twice as fast as normal items. Feel free to make any changes to update quality method and add any new code as long as everything still works. However, do not alter the item class or item properties, as those belong to the goblin in the corner who will insta-rage and one-shot you as he doesn't believe in shared code ownership. You can make the update quality method and item properties static if you like, we'll cover you. Just for clarification, an item can never have its quality increase above 50, however Sulphurous is legendary and has quality of 80 and never alters. So what I'm going to do now is the 50p, 20p refactoring side of this, so they kind of get it to a point where we can get some characterization tests round what I'm kind of assuming is a core bit of code, which is the update quality function. I speeded this up because it's a little bit tedious. The basics of this is I'm going to take the same input that the actual console app has. I'm going to use that as my starting point. I'm going to run the code update function, which I've made static, and I'm going to assert using Fluent Assertions, which aren't installed. So at this point I actually wandered off into a black hole of NuGet package and framework hell, and it took me quite a while to get it back to a state where it was actually functioning properly, but nevertheless we managed to get the NuGet package installed and the framework version updated to 4.8. So now I can actually create a expected value, which I'm just going to copy the input at this point, because we're going to actually use running the code, which we're taking the code as being working at this point. When working with legacy code, you can only really assert that its behavior has not changed. You can't really assert that its behavior is correct. You have to assume that to a certain extent. So using Fluent Assertions, we're going to assert that the result should be equivalent to the expected. And then we can run this test. And it should fail. And it does. So now we can take the the differences between the expected values and the actual values returned in the test at the bottom here, and we can map those in. So now I've got a bit of speeded up me adding all these tests in. What we're basically doing is starting at the same point, doing an update quality for a number of days, and then asserting that the resultant stock we've got has the right values, so the things have degraded as we expect. And we're doing that in a characterization manner, so we're literally just taking what the application comes out with as being the right answer and asserting that in the test. So it means that later on, when we're doing changes to the code, or we're doing any refactoring to the inner workings of this, we can make sure that it does actually still work. One of the things you'll notice here is I'm just adding an aggregate link function to make the running of that number of days a little bit simpler and a little bit more reusable for these tests. So at the end of this bit, we do actually end up with a suite of tests that are reasonably cleanly written. Had some little dilemmas over naming conventions, as I quite often do. So what I'm going to do now is actually run cover over these tests. So this gives me an idea of if there's any code path that I've missed. And as you can see from that, we've actually got a 100% test coverage in the bits we're interested in. So the item class and the update function, 100% coverage, which is about as good as we can expect. In fact, that's far better than you usually expect for characterization tests. So we've got some comfort there that we are asserting the current behavior of this application. So I'm going to check that stuff in, and that's going up to GitHub, which I'll make available at the end of this. So the obvious thing to do, now we've got a nice working set of tests, is we're going to change it all. We're going to refactor these into a theory. So that's changing these so you've got one test, but a varied input set into that single test. So it's a theory. So the first thing we're going to do is just tidy up some of the structure that we've got in this first test, because we need to use this as a foundation for our theory. So I'm going to pull in having a variable for the expected, and then we're going to pull that into a member function we're going to call data, which I've got down here, and a member data function actually has to be static. So I will notice the fact that static is missing there, and there we go. So now it's just a matter of going through and pulling all these other tests into the data, and once we've done all that, we can get rid of the original tests. So now we've got an improved, refactored set of tests that are using a theory as opposed to lots of facts. We can check those changes in. Again, I'm checking this straight into the master branch of my GitHub clone, which will be available at the end of this series. So that concludes this very first part of our journey into refactoring and adding functionality to legacy code in the form of the Gilded Rose Kata. In this episode, we've covered adding characterization tests around the existing code to assert its behavior is, as well as we can do, expected. In the next episode, we're going to look at how we can start to refactor the core code on the production side to make that much easier to read, so that we can eventually make that change that's required. If you don't want to miss that episode, why not click on subscribe and click on the bell so you get notifications when I release new videos. Thanks for listening, and thanks for watching.